Okay, so for now, we're now going to focus on projectile motion, and rather than doing the formulas, which we've just worked out, of course, you need to know how to get these formulas. That the technique is very important. Now what I want to focus on now is we're now going to look at different projectile motions with different velocities and different theta, and see how it will affect the projectile motion in general. So how will it affect the time of flight, how it will affect the range, how it will affect the max height. Does it make sense?
Yeah.
So, and we'll also look at G. G is not usually varied too much. Sometimes they do it vary in G in physics, but let's just look at how each of these three sort of things is going to be affected by the variables of V, theta, and G. So if V goes up, in other words, you're launching faster, what do you think happens to the time of flight of the projectile?
Increases.
Right. I mean, does that make logical sense?
Yeah, that does.
Right. We basically throw it harder and it's in the air for longer. That's kind of, as you expect. What do you think happens to the range?
The range increases.
Right. The range also increases. Now, for my purposes, what I'll do right now is I'm going to just flip these around.
Yeah.
For now. So yes, the range does indeed increase. All right.
Yeah.
What about the max height?
Increases as well.
Right. I mean, all of those make sense. So as you throw it harder at the same angle, you would expect that, well, it stays in the air longer, it goes higher, and it goes further. All right.
Yeah.
Now, what if how does time of flight affected by theta?
Oh, it's the same if you think about it logically. The harder of an angle you throw in respect to the ground, the longer the time for the flight.
When you say higher, how high? Like when you say the angle, how big can the angle get? To be clear.
Up to 90.
Right. So not obtuse, right? Because then you're throwing it the other way and it starts going lower. So as theta approaches 90 degrees, then time of flight goes up. Yeah. What about max height?
Also goes up.
Right. So we expect it to go up as theta goes up across, if assuming theta is acute, which is basically all your questions, then as theta goes towards 90 degrees, then max height goes up.
Yeah.
In fact, we would say that when theta equals 90 degrees, then time of flight is maximum, right?
The highest, yeah.
And as theta equals 90 degrees, time of max height is, well, h is the maximum max height you can get, right?
Yeah.
For that velocity.
Yeah.
And on the other hand, if it's 0, then it's the minimum, and it's not even in the air, right? You essentially just drop it immediately. Yeah. All right. What about range? How is range affected by theta?
Range is because thinking about it is whenever as it approaches towards 0, your range increases.
That's not quite true. So it sounds like you're having a little bit more difficulty with range. So let's leave range for the moment. And let's just focus on time of flight and max height for now. Yeah. So what about G?
So as your G increases, your time of flight decreases.
Yep. And that
makes sense.
Makes sense as well, right?
Because if you're accelerating, yes, finishes faster.
Yeah, it's getting pulled down faster, right? And as G goes up, what happens to your max height?
Your max height decreases.
Right. And all of that is borne out by our formulas as well, right? We've got formulas that would suggest that, the V, as V goes up, these go up. As theta goes to 90, then sine maximizes, and that's sine squared, so that maximizes. And so not only is H goes to H max, but we know that's going to equal V squared over 2G specifically. And that's just going to equal 2V over G as well, specifically. All right. So focusing just on time of flight and max height, do you notice anything about the relationships?
It's basically the same idea.
Basically, time of flight seems to react in the same way to max height when certain variables are sort of changed, right?
Yeah.
So we probably should examine, is there a relationship between time of flight and max height?
Yeah.
So is there?
Time of flight and max height. There is.
What might that relationship be if there is?
Because the higher the larger that time of flight is, the more because you divide because the your max height is achieved by using the formula of how your time of flight is halved. So the higher of that will be, the higher your t variable will be when you're calculating
That doesn't mean
h.
it's higher though. I mean, just because just saying t is larger doesn't mean it's higher. I mean, it comes back down, so you can't say just because t is larger, it's got to be higher, unless you kind of give a bit more justification.
Well, this time in terms of time, it means time in the ground, in the sky, and
Yeah,
the higher the time in the sky, the higher it will be eventually.
sure. I guess in a way, conceptually, you're right. So if you're happy with that thinking, then yes, you're not wrong. You're right that the fact it stays in the air for longer means it has to kind of go higher. And if you're thinking about it vertically only, that is true. I'm going to prove it mathematically. All right.
Okay.
But you're right. So we have these two formulas.
Yeah.
And well, if we consider, I mean, we're just trying to sort of get them related. So you've got squares here. So let's square time of flight. All right. So if we square time of flight, we're going to get 4v squared sine squared theta over g squared, right? And you can probably see that a lot of similarities are already happening. You've got the v squared sine squared theta. You have a g already. And you've got a 4, which we don't have in the h. And we've got a g that we don't have in the h. Like, you agree that these two things are the same, right?
Yeah. But why do you times t
Well,
squared?
I'm trying to, get h in. So this has a 2 in the denominator, right?
Yeah.
So if I put 2 in the denominator, I can cancel it out by multiplying by 2, right? I mean, that those 2's just cancel, right?
Yeah.
And then if you focus on this thing that I'm going to put in green brackets, what is that?
That is your h.
In other words, algebraically, TF squared is just 8 over GH.
Okay. What does that say? 8 on 8.
8 on G.
Okay.
So what that means then is there is a direct correlation between the time of flight and H. So we can say, I mean, that pretty much proves it, but we can basically say H must equal G times TF all squared all over 8, right?
Yeah.
Or we could say that TF must equal the square root, so 2 root 2 over root G times root capital H. In other words, and these are just constants. These are just constants. Does that make sense?
Yeah.
In other words, the key point that you want to take it out of this is not necessarily the mathematical formula, but the answer to this is yes, there is a relationship. And what that means then, is that if you know the time of flight, then you know the max height. And if you know the max height, you know the time of flight. And you don't need to actually know the relationship. You're not going to be asked to work out the time of flight from the max height or vice versa. It's unlikely you'll be asked that. But more importantly, what I'm trying to get through to you here is that any projectile motion with the same max height must have the same time of flight.
Yeah.
Without exception.
Yeah.
So all projectile motions with same max height must have the same time of flight.
T. Yeah, because yeah, only due to gravity.
So in other words, we could have very different projectile motions, all launched in different ways, in
Yeah.
different velocities, and different angles. So for example, I could have projectile 1, projectile 2, projectile 3, projectile 4.
Yeah.
Because I don't need to do any calculations, because all projectiles have the same max height,
Time of flight is the same.
they must all land, like they must have the same time of flight.
Oh, that's kind of weird, but yeah.
Or in other words, if I fired all these projectiles off at the same time, they would all land at the same time.
Yeah, but wouldn't the range be very different?
Yeah, the range will be different, but I didn't say anything about the range. I just said that they would, if they fired at the same time and reach the same max height, then they will land at the same time. I didn't say they'll land at the same spot. I did not say that they have the same path.
Yeah.
I simply
Yeah.
said the time of flight would be the same.
Yeah. Okay.
And that's something that will be often very helpful in terms of understanding for a lot of questions that you'll be coming across.
Okay. Is that the reason why one of the scientists, is it Galileo? I'm not sure, who got killed when doing this experiment on a tower because
Sorry,
it
I'm
was
not
challenging.
sure what you're saying there.
Ah, okay, right.
Yeah. All right. Any questions with what we covered today?
No,
Okay.
not thus
So
far.
that will set you up to do a lot of the calculations. We still need to
Okay.
talk about how range is varied and the different sort of nuances and concepts with range. But we'll
Yep.
do that next time. Now,
Okay.
yeah, but you should be okay with doing basic calculations. So, max height, range, time of flight, which come to the questions. And because we focus on the techniques, you can probably also try to apply them to not level ground questions, which you may get. So you can give that a go. Yeah.
Yeah.